Here on Earth, we are used to a very predictable weather cycle. Water evaporates into the atmosphere, condenses into clouds, and eventually falls back down as rain. But when you look at the massive exoplanets and gas giants scattered across our galaxy, that familiar cycle is completely absent, replaced by volatile and highly reactive atmospheres. Deep in our solar system, massive weather systems don't produce water droplets. Instead, they are raining millions of carats of solid diamonds. These are continent-sized storm fronts, precipitating immense volumes of crystalline wealth continuously into the dark. This is a physical reality currently unfolding on our nearest cosmic neighbors. To understand this, we have to look at Neptune. It is an ice giant, defined by a thick, highly active atmospheric shell. The upper layers of that shell are heavily saturated with methane gas. Through these upper layers, extreme electrical storms and high-energy lightning strikes tear across the cloud tops. When those massive electrical shocks hit the methane molecules, they sever the chemical bonds, stripping the hydrogen away and leaving the single carbon atoms completely exposed. Without the hydrogen, these heavy, raw carbon atoms clump together and immediately begin sinking through the lighter gases below. The violent storms at the surface are essentially a harvesting system, collecting the raw material needed for a much more intense physical process further down. As that carbon plummets thousands of miles deep into the planet, the sheer weight of the atmosphere above it begins to compound. The material is subjected to extreme planetary scale compression, while the surrounding temperatures soar to thousands of degrees. Under this specific, crushing combination of heat and pressure, the carbon atoms are forced into a rigid, highly organized state, bonding together to form crystalline structures. The resulting structures are rough, solid diamond hailstones, which continue to crash downward toward the planetary core. Neptune operates as a massive geological forge, utilizing intense physics to manufacture the hardest known gemstone directly out of its atmospheric gases. Because this is occurring thousands of miles beneath the surface of an inaccessible gas giant, it raises a necessary question about how we can verify these conditions. Physicists have actually bypassed the need to send probes into the planet by recreating Neptune's core conditions inside laboratories right here on Earth. In recent experiments, researchers took carbon-rich plastics and fired incredibly high-powered optical lasers directly at them. The sudden laser impacts generated massive micro-shockwaves through the material, perfectly mimicking the intense heat and crushing pressure of Neptune's interior for a fraction of a second. When they analyzed the remaining residue, the scientists successfully recovered real, newly forged nanodiamonds. By replicating this precise chemical reaction in a controlled environment, we can confirm that this deep space weather anomaly is an observable physical fact.